Okay, Unit 2, Day 2. Now we've worked with complex numbers. Now we are going to use them in equations. And we're going to find solutions, okay? So every quadratic equation has complex number solutions that sometimes are real numbers. Some quadratic equations have some pure imaginary numbers. That's just complex number solutions. Okay? Equality property for complex numbers. If two complex numbers are equal, then the real parts are equal and the imaginary parts are equal. So say we have a plus bi equals c plus di, then a equals c and b equals d. Okay? The product of a non-zero complex number is the product property of complex numbers. So that's a plus bi times a minus bi is a squared plus b squared. If you notice, that is perfect cubes, or perfect squares, so that's the sum of squares, which we've done last unit. Okay? And then ignore that last one, I guess. Every polynomial with complex coefficients and of degree n, blah, blah, blah. That's the fundamental theorem of algebra. I'll go through that more once we get to examples of it. The reciprocal of a complex number z and 1 over z, where z cannot equal 0. That's the multiplicative inverse of a complex number. Lots of words, just write it down, okay? And then sum and product of the roots for ax squared plus bx plus c equals 0. Sum of the roots is negative b over a. Product is c over a. We'll get into more examples that will make more sense once we get into those, okay? So finding imaginary solutions. We only have two terms here. So we have 5x squared plus 20 equals 0. So we have a squared term and then a constant. All right, let's just solve this using the square root method. So I'm going to subtract 20 from both sides. I get 5x squared equals negative 20. Divide by 5. I get x squared equals negative 4. Square root both sides. I get x equals plus or minus 2i. Since this is a solution, we have to pull out the plus or minus. So it's plus or minus 2i. We should have done that last video too, I just forgot. Okay? Let's do b. So we're going to subtract the 15. You get x squared equals negative 15. Square root both sides. You get x equals plus or minus I, because you can pull out an I. That's all you can pull out, though. Square roots of 15. Okay? Those ones are pretty straightforward and simple. Let's get into some more complicated ones. So first, let's look at a. So we're going to use the equality property here. Remember, a plus bi equals c plus di. We have i's in both sides, so we have our a's and c's, okay? Or a's and c's and b's and d's. So I'm going to set 3x equal to negative 18. I'm also going to set 5yi equal to 20i. Okay, notice how I set my I terms equal to each other and I set my other terms equal to each other. And I have two variables here, so I can do that. Then in this first one, I'm going to solve for x. So I divide by 3. I get x equals negative 6. In this second one, I'm going to solve for y. So I'm going to divide by 5i to both sides. 20 divided by 5 is 4. I divided by I cancels. So I get x equals negative 6. Y equals 4. We're done with that one. Okay? So notice in that one I had two variables because I had x and y. Now let's look at c. C, I only have one variable. So this one gets a little bit more complicated, okay? So I only have x's. So we have to get all our x's to one side and we're going to move everything else to the other side. So I'm going to add my 1 minus I x to both sides. So I end up with 3 minus 5i, because that just stayed, plus 2ix plus 1 minus I times x equals 3i. So I just moved that over. Now I'm going to move the 3 and the 5i over. So I'm going to subtract 3 and add 5i to both sides. When you do that, you get 2ix plus 1 minus I times x equals 3i minus 3 plus 5i. Okay. I combine those on the left or on the right and you get 8i minus 3. Now if we look at the left side of this equation, we have x's in both of those terms, right? Which means I can factor out an x. And by factor out, let me go back. So when you factor that out, basically, this one can be divided by x. This one can be divided by x. So I'm just going to take that x out, and I'm left with 2i, and then plus the I, or plus 1 minus I. Okay, so that's where that came from, because I could just factor out that x. This drawing is going to go away in just a second. So I just factored out that x. Then I need to just combine my i's, so I get x times 1 plus 1, or I plus 1 equals 8i minus 3. To get the x by itself, I divide by I plus 1. So you get x equals 8i minus 3 over I plus 1. Now this is the part where it gets a little tricky. Mathematicians do not like I in the denominator. So we have to use the conjugate, okay? So I'm going to multiply by I minus 1. The bottom is I plus 1, so I'm going to multiply by I minus 1. I just changed the sign. When you multiply that out, you can use distribution, you can use the box. It doesn't matter. But you'll end up with 8i squared minus 8i minus 3i plus 3 on the top. I squared minus I plus I minus 1 on the bottom. Remember, I squared equals negative 1, so I'm just going to plug negative 1 in for I squared. You end up with negative 8 minus 11i plus 3 over negative 2. Combine your like terms there. You get negative 5 minus 11i over negative 2. Notice how those were all negative? All these right here. That's a negative, that's a negative, that's a negative. I can just switch all those signs, change them all to positives. So that's 5 plus 11i over 2. And you can leave your answer in that form, or you can whatever, change them. So it's 5 over 2 plus 11i over 2. So you can split them up or you can keep them all together. I'm fine with either answer. Okay? So finding pure imaginary solutions, or just imaginary solutions. So here you could try and use the x, or you could try and use the slip and slide method. I'm just going to tell you it doesn't work. So we have to use quadratic formula, which is something you guys should have learned last year. So let's just pull this up.
The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, fun little song. That's just an easy way to remember it. I'm going to link that YouTube video onto the Canvas page also. But so that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, a is always your first term, b is the second term, c is the last one. So in this case, a equals 3, b equals negative 1, c equals 2. Then you just plug those into the formula. So that's x equals negative 1 plus or minus the square root, negative 1 squared minus 4 times 3 times 2, all over 2 times 3. And notice every time I put those variables in, so like for b, I always put them in parentheses. You should do that also, okay? You just simplify this down. So negative times negative 1 is positive 1 plus or minus. Negative 1 squared is 1 minus 4 times 3 times 2. All over 2 times 3 is 6. Finish simplifying that out. That's 1 plus or minus the square root of 1 minus 24 over 6. That's 1 plus or minus negative 23, the square root of negative 23 over 6. You can just pull out an I, so that's 1 plus or minus I squared root of 23 over 6. Okay, so that's your answer. And I want you to notice that there's two solutions here. So we have x equals 1 plus I square root of 23 over 6. And we also have x equals 1 minus I square root of 23 over 6. So there are two solutions there. That plus or minus means there's two. Okay? All right, so we have to find the reciprocal, then use the complex conjugates to simplify. So first, the reciprocal. That just means you flip it, you put it over or under 1. So the reciprocal of 3 plus 2i is 1 over 3 plus 2i. Then the conjugate of 3 plus 2i is 3 minus 2i. You multiply that out, so you get 3 minus 2i, 9 minus 6i plus 6i minus 4i squared. Those 6i's cancel. 9 minus 4 times I squared equals -1. So that's 3 minus 2i over 9 plus 4, which is 3 minus 2i over 13. You could leave it like that, or you can split it up. So that's 3 over 13 minus 2 over 13i. That's it. Okay. Please remember to take the quiz. If this stuff confused you, go back and rewatch it. We're going to do a lot of practice tomorrow. Okay? I'll see you then.